Students are now applying their knowledge of the coordinate plane and the definition of a reflection, translation, and rotation of a two-dimensional figure to develop algebraic rules for the coordinates of a pre-image and image. New learning to this standard is the concept of a non-rigid transformation, specifically known as a dilation. Using these formalized algebraic rules, students will determine coordinates of any figure after a given transformation. This standard has a focus on reflections over horizontal and vertical lines, as well as a focus on rotations around any point within a single transformation, and rotations around the origin within a series of transformations. Sometimes vocabulary can make or break students' understanding of a concept. When discussing geometry concepts, it is important for students to know proper vocabulary. One instructional strategy you can use is introduce transformation vocabulary using Robert Kaplinsky's Miss Pac-Man 3-act task. This task creates the conversation about movement on a coordinate grid. Take a look at the terms these students use to describe Miss Pac-Man's movement. During a whole group discussion, the math language can be attached to the terms developed by the students. This makes the vocabulary more meaningful to students. These students are completing a formative assessment called concept card mapping. This assessment helps to activate prior knowledge, allows students to make connections between terms, and creates a visual representation of connections within their own level of understanding. Concept card mapping can be implemented at the beginning, middle, and/or end of a unit of study. Students were given 12 words and asked to group them based on any relationship they identified. It's one of mine, yeah. You're looking at the cards to see which ones you feel together. Move them over because Pinter's working with you guys as well.
And what about this word?
Shrink and grow.
Oh, never mind. This and rotation. This one. And then check.
I
put this one. And
they were just in my face.
The video clips you are about to watch show instructional strategies for deriving rules for rotations and reflections. Allowing time to derive rules rather than focusing on memorization moves students along a continuum from an instructional understanding, doing something without understanding, to a relational understanding, which is knowing what to do and why.
You want to make sure the holes line up as well. So you want this hole to line up. There you go. And now you're going to set it directly on the axis. So
The mathematical tool used to help students with reflection is called a mirror. As you watch, take a moment to record what you notice is happening.
Well, we're going to use it for a particular reason here. If you notice at the bottom of your mirror, there's kind of like a groove in the bottom of your mirror. You want that part to be towards the table when you get ready to use it, if that makes sense. Does everybody understand what I'm saying about the groove at the bottom? Okay. All right. So take a moment, go ahead and look through the mirror so you can see how things turn purple. Look at everybody purple.
When working with any new manipulative, be sure to allot 1 to 2 minutes of exploration and playtime. Students become naturally curious and creative when provided concrete materials.
Directly on top of the x-axis on your XY pegboard in front of your triangle. So if you have a peg in the middle and at the origin, go ahead and remove that peg so that it can sit flat. Okay? And look into your mirror and tell me, what do you notice in your mirror?
The reflection.
Is it flat? Say that again.
The reflection.
The reflection of what?
The
right
You see the reflection of your right triangle, and it's almost as if it's sitting on the other side of the XY pegboard, right? And I love how Pedro has already jumped to it, and I was just getting ready to ask you guys to do that. Go ahead and place new pegs where you see them in the mirror. Make sure your mirror is sitting directly on the x-axis, because if not, it's going to throw off your reflection. The x-axis. So Tony, give us the points for your image, your pre-image, excuse me. That's your original.
Well, I got 1, -1.
1 negative 6 and 6 negative 6.
6 negative 6. All right, so here are the points for his original, his pre-image. Give us the points for your second one. Your
1 comma 1. 1 negative 6 and 6 negative 6. I mean 6 positive 6.
Okay.
The B is positive. The negative 6.
Like that? Okay. So let's look at from A to A prime, what changed?
Through the investigation, students concluded reflecting over the x-axis results in the changes recorded here as stated by a student within the class. After investigating a reflection over the y-axis, students concluded the x-coordinate became its opposite and the y-coordinate remained the same. Another point you want to guide students to discovering is the point's distances from the line of reflection. The benefit of using transparency paper or patty paper as a tool of transformation is the use of its vertical or horizontal position to accurately rotate a shape. Here's a suggestion for using it to derive rules for counterclockwise rotations. Have students draw a shape such as a scalene triangle on a coordinate grid and trace it onto the transparency or patty paper.
And now, if you would please, go ahead and make a 90-degree turn counterclockwise. Great job, Jeff.
God.
Once students complete the rotation, require them to record the points of the image. As a class, you can discuss any conjectures made by analyzing the points of the pre-image and the image. When making a 180-degree counterclockwise rotation, be sure students begin in the original location or on top of the pre-image. Notice how this student uses the vertical positioning of the transparency paper to make an accurate rotation. The points are recorded and compared to determine the rule. Here, the teacher captured student thinking by recording the information on an anchor chart. This can now be used as a resource for students as they recall the investigation,
A was on the bottom,
as you will hear in the
C
following
was on the
clip.
top, and B was in the middle.
Okay, and then when you think about, so remember how the original A was 2, 7? When you rotated it 180 degrees, was it -2, -7, or was it different?
It was -2, -7.
It was -2, -7? Okay. And so how did that help you with answering this problem right here?
When you spin on the origin, it automatically tells you where the triangle is. You don't have to. All you gotta do is find the points of each plot for the 180 degrees.
Okay, and so when you were answering this question right here, did you use the rule that we figured out with the clear paper and the triangle to help
Yes.
you with this one? Okay, and so what did you know, if you were going to make a 180 degrees, what did you know about the X and Y? What was going to happen with X and Y?
The X and Y, the X turns negative and the Y, they just stay the same, but they just turn negative.
All right, awesome. Thank you for sharing. This test gives students a chance to explore several issues relating to rigid transformations of a triangle and triangle congruence. It addresses GSE8 G2 as it can help students build their understanding of the relationship between rigid transformations and congruence. And although it does not require students to explicitly describe the transformation in terms of coordinates, the teacher could lead a discussion about how to describe each of the transformations using coordinates, making this task suitable for GSE 8 G3. Have you ever used games for practice within the classroom? This one is called Transformation Game from EnrichMaths.Org. In this game, 2 to 4 players use the game board and are dealt 5 cards from the provided deck. When it is a player's turn, She or he must try to move the playing piece from where it is on the board to one of the other marked triangles. She or he must use a transformation or combinations of transformations, which is determined by the cards within their hand. An added component would be to require students to determine the rule they would use to complete the transformations.